And welcome back to the Turdferg Show. Hey, today's video is on cycloalkanes, or alkenes, or whatever you want for that matter. Basically, what do you do when instead of a chain, you see this formation? So anyway, let's just go ahead and get straight into it. And this is no big deal. All you got to do, if you see one of these two structures, this cyclo structure, is you're just going to add the word cyclo into the problem. So if you're already in knowledge, say for example, how would you name this? 1, 2, 3, 4, 5, 6. 6 C's, all single bonds. You would call it hexane. Well, here's the thing. These two structures are both very similar in that regard. The only thing you'll do different is this. Add the word cyclo in front of it. So this would be cyclohexane. And that is all we have to do to get the name for this. So very easy to do this. So take a look at this. 1, 2, 3, 4, 5 C's. And so normally we call it pentane, but it's in this formation, so we'll call it cyclopentane. And that is all we have to do to name that one. Now, we never went through it. I've got some other videos up here. What's known as a skeleton structure. This would be a huge pain in the rear end to actually have to sit here and draw all these C's out every single time. So what you're going to see me do from here on out is draw a hexagon like this. And the way this drawing is represented, when you see this, each one of these locations represents a C. So it lets you draw this real fast and in a hurry. And all you've got to do is be able to draw that. So there's cyclohexane again. That's all you have to do to draw it. Now, I'm a little bit lazy to do that, so I have the ability to generate cyclohexanes like that, so I'll kind of cheat and go with the prefab models. So let's go ahead and do something. What if, and I've got some just randomly laying around, let's go ahead and have some fun. What would you do if, let's say you had a double bond in there? What would you call this compound? Well, easy. What would you normally call one? Well, if you saw a double bond, what should pop in your head is the word hexene. And like normal, you need to say where it's at. A lot of people get confused on this. Where do you start number one? Well, I'll give you a hint. Number one needs to be with the bond. And now, in other words, it doesn't matter where you put it, but it needs to be with this bond. And now, here'd be the question. Are we going to go clockwise or counterclockwise? Well, if I make that number one, I'm going to go counterclockwise because I want the double bond to be at the beginning of this. 1, 2, 3, 4, 5, 6. So what I would call that would be 1 dash cyclohexene. And reality is, I didn't really even need a 1 on this one because it's cyclohexene. It didn't matter where the double bond is, it's still going to be the same looking structure. So I could kind of skipped it there. Well, let's do this. Let's have a little bit more fun. Let's put a double in here. Oh, let's get crazy. Let's do 2 doubles. And let's do this. Let's throw, ooh, I got this. Ooh, bam. Let's throw us in a couple of those. And hey, how about this? Let's throw a bromine on there to boot. So we've got a lot going on in this question. First thing first, we need to number this. And if I've got a halogen, if you've watched the other videos, I like making my halogen number 1. But now we got a big question. Which direction do I want to go? And I'm going to go ahead and number it this way. And I'm going to go ahead and knock those double bonds out as quick as I can. 5, 6. So in this case, I would call this 1 dash bromo. And except for me, I wrote the letter D. So let's get rid of that. 1 dash bromo. And I'm starting to think I probably need a little bit more room because this one's probably going to end up kind of long. 1 dash bromo dash 5, 6 dimethyl. And then I'm going to go dash, I got to address these doubles. 1 and 3. 1, 3 cyclo, where am I? Hexagon. diene. So let's look at the big things. The dimethyl, because of the two methyls, I got the bromo. The word cyclo shows up because it's this ring structure, and I've got the di in front of the ene, which means there's a double bond in there. So it's kind of give you a decent little idea. How about this one? Could you name this? This is an extremely common structure you'll see in organic. And so once again, we'll go and we'll pick one of these to be number one. Here, number 1, 2, 3, 4, 5, 6. So let's name that one. 1, 3, 1, 3, 5, cyclohexatriene. Now, there you go. There's that one. But here's the thing. This one shows up so often in chemistry. Like literally, it shows up so often that we just have a name for this. We'll call this a benzene ring. Benzene. So whenever you hear the word benzene, benzene is another way of saying 1,3,5 cyclohexatriene without having to go through all the trouble of the 1,3,5 cyclohexatriene. Now, we've even got a way of writing this a little bit easier. So if you're trying to do the skeleton of benzene, the skeleton of benzene is you just draw your normal structure and put a circle like that. So whenever you see me do this, that represents this same bonding pattern that you see right here. That's just a skeleton. So if I saw that, I'd call it benzene. Well, what would you do? Let's say, for example, you had this C, and I don't want to change my color pattern. Say you had a C there and a Cl there. All I would do is I would call this 1, 2, and 3, 4, 5, 6. I would call it 1-chloro dash 2-methyl benzene. And see, if I didn't have this way of saying benzene, it would have been dash 2-methyl dash 1,3,5 cyclohexatriene. So this benzene really saves us a little time. Now I'm going to go ahead and take advantage of one more thing with like the benzenes, and that's what to do if you have here. Let's look at this. Now, this is a very common trick question. These are two different things. This is two completely different things. This is a benzene ring because you see the little circle inside, which represents the doubles in there. This, on the other hand, is just cyclohexane. So if you see an OH attached like this, what should trigger in your mind? Well, that's an alcohol. So you're going to put an OL. So this is a cyclo. So this one would just be cyclohexanol. And that's all you'd have to do. Yeah, you could put 1 dash, but what would be the purpose in that 1 dash? Because it's obviously wherever the all is, that will be your number 1. This, on the other hand, you might be trying to figure out, do you call this like benzene all? No, this is actually what's known as, I'm going to do my little quotation marks. When you see a benzene ring with an alcohol like this attached to it, it's called a phenol. And that's one of those things you just got to memorize. So really, from this video, what you should have now is this. You should be familiar with what to do if you have a ring structure. And if you have that ring structure, you just add the word cyclo. What do you do if, let's pull this one in, you see a ring with 3 double bonds, which can represent with a circle, hopefully neater than that. But we call that a benzene, and you literally put that in the name. And then you should also have, after watching this video, if you see, let's see if I can unclick that, benzene with an OH, that's called a phenol. And really, that's kind of ugly what I just did, so phenol. So at the conclusion of this video, you should be able to identify and name these structures. But anyway, as always,